So that's what we're doing today. The reading is also assigned, so please click on the reading and take a look at that, and don't just guess your way through the multiple choice questions. We don't do an immense amount of assignments here in this class, so make sure you're getting the best grades you can. And some of y'all need to be padding your grades. Get those grades up above that 70 level, so when it comes to the last 6 weeks, you're not having to scramble to get that passing grade. Y'all, more than anybody in my chemistry classes, are on the verge of graduation. So please make sure you're getting all the grades that you need to get to get out of here, so you don't have to see me again and sit through this class again. That would not be great to do. So use the reading. Use it to help you get to the answer in all the questions. Let's take a look at some of these questions real quick. Well, it's not going to open up. There we go. So we got 15 questions. Not too bad. A lot of them we've already gone over. They ask about the San Andreas Fault, and so I talked about the type of plate boundary that was at the San Andreas Fault yesterday. And let's go ahead and go to the one that doesn't have all the answers on it. Thank you.
Yeah, I got one.
Yeah, we got one. Luckily, that was the easy one that I've already given you the answer for, so hopefully it wasn't too bad. Pangea became the continents we see today because of what? So everything in Pangea was together, and now it's started to spread out all over the world. So you need two different types of plate boundaries to kind of help you get to that point. What is a byproduct of subduction? I talked about subduction, and subduction is where you have one plate being pushed underneath another. So when this oceanic plate, gets pushed down beneath the continental plate, what kind of stuff is happening there? All of this is going to be in the reading. They went over this pretty thoroughly through the reading. There is several pages, so if you go to Explore, I think we have 4 pages here that you can look through. But for the most part, I think we're mostly going to be on the first page or the second page. So they talk a little bit about convergent boundaries, and then they go to divergent boundaries. So not too bad. Deep sea trenches are associated with which of the following? So I also talked about that, how you get your deep sea trenches, your Marianas Trench, where you have your oceanic plate being pushed underneath your continental plate. They kind of hook up a little bit, and the continental plate gets dragged down with the oceanic plate, and that little like trench that you get there is going to be your deep sea trench, like your Marianas Trench. A geologist is studying an ancient syncline in the Appalachian Mountains. How is this feature formed? They still haven't gone over this, so let me actually see where they're going to get to this structural stuff, because I don't believe they've talked about it yet. And Discovery Education does that quite a bit. Get ahead of themselves. Plate tectonics, igneous rocks. Oceans, atmosphere. Yeah, I don't know that they talk about it at all. I don't know. I guess it's somewhere in here. Continental drift, evidence for plate tectonics. You got the rock cycle. It's not going to be in earthquakes. Yeah, I don't really know. They don't really have a section over it, so it's possible that it's in here, but I didn't really see any of it. So let's do this. I'll do my little spiel that I do for my dual credit classes, because they're not going to have anything here. So everybody real quick, because they ask about this, so I'll give it to you all this way. So when I squeeze together rocks, when we have convergent boundaries or a compression type of stuff, and I have a bunch of rock layers like this, I squeeze them together, what's going to happen to them? They're going to fold up. But I have different ways that these can fold. So basically, I have 2 ways that this can happen, and they kind of happen together. You'll get something kind of like this as opposed to just one of them. But basically, they can fold up, if I can get it. They can fold up, or they can fold down. And these are actually two very different things, because if we go back to the law of superposition, as far as ages, what's on the bottom and what's on the top? Yes, the oldest is on the bottom and the youngest is on the top, because you got to put the bottom layers on first and then you can stack them up younger. So when I squeeze this to go up, the oldest stuff is on the inside and the youngest stuff is on the outside. Where if I squeeze it to go down, the youngest stuff is on the inside, the oldest stuff on the outside. They have two names for these. And I'm not going to write on the board. I'll just show y'all. So if you're paying attention, you'll get it. If you're not, you're not. The way I remember these, up is called an anticline. Why? Because it points up, and hopefully your auntie is a nice lady, and when she passes away, she will go up to heaven. Does everybody get that? Just a second. It sounds weird, but when you see the next one, you're like, okay, I got it. So anticline is up because your auntie goes to heaven. Syncline is down because if you sin, you don't go to heaven. You go down to hell, to purgatory forever and ever and ever. So that's why I remember them. Up is anticline, down is syncline. That's the difference between those two bands. And so when they ask, this geologist is studying an ancient syncline in the Appalachian Mountains. How did this feature form? The syncline is going to be pushing down, but how did I get it to push down? I had squeezing. I had compression that happened. Let's see. Each side plate boundary is associated with a different primary force. Which of the following pairings of plate boundaries and forces is correct? So basically, you got to think, if it's convergent and coming together, is it getting squeezed or is it getting pulled? If it's divergent and separating apart, is it getting squeezed or is it getting pulled? A geologist is studying the Franciscan age assemblage of Northern California, a melange of sediments that originally formed in the ocean. How might this unit most likely have formed? Okay, this is something, again, did they go over melanges? Let's see if they got it in here. I think that's going to be in your accretions, which is on the next page. Subduction zones, trenches. They talk about trenches, volcanoes, folded mountains. They talk about synclines and anticlines. There they go. So they do talk about anticlines and synclines here in the folded mountains section. They give you that description of what an anticline and a syncline is. Fault block mountains, wonderful. Accreted terrains. That's going to be where your melange is. The spice must flow. Yes, so basically with that one, where they talk about the accreted terrains on number 7, is that the one you asked about earlier, Terry? Or did you just say 7 out loud? Never mind. But anyways, if you have questions on number 7, basically what's happening when you have a melange of sediments is you have one plate being subducted underneath another one or sliding past another one, and you're getting a bunch of different rocks like scraped off. I'm going to guess it's got to be C. Yeah, on this one. I'm going to be honest, they didn't go over that too well in the readings. So that one's going to be C. Accretion of rock on crust during a mountain building event. Unless I'm completely wrong, which has happened before for sure. Number 8, hypothetical supercontinent moves over the North Pole. How do geologists think this event could affect the planet with a supercontinent over the North Pole? Yeah, I don't know. Supercontinent over the North Pole. I don't know what that would do. Do they have... That's probably going to be on the last page here, if they have an explanation for that at all. Let's see. Maybe it's on the third page. Evolution, yeah. Ocean currents, nah. Global change. Here we go. So this is where they talk about that. About 1.1 billion years ago, the formation of the supercontinent Rodinia formed a landmass that stretched from the South Pole to the equator. Scientists describe the climate during this event as snowball Earth, a hypothetical scenario describing the planet plunging into freezing conditions. The formation with Rodinia coincides with a series of devastating glacial events. Ice and snow covered Rodinia. Scientists even suggest that glaciers formed at the equator. The equator might have been as cold as present-day Antarctica. I don't know that they're really making a great argument there, but we'll go with it. So I believe they're telling us that it's going to get an icehouse climate, although I don't know that they've really supported that very well, but that's what they're saying. Number 9, a geologist is comparing volcanism at 2 different locations. Location A is a volcanic arc system. Location B is a spreading center. Which conclusion is the geologist most justified in making? Comparing volcanism at 2 different locations. So volcanic arc, spreading center. I'll just tell you, the volcanic arc system is going to have bigger volcanoes that erupt more often. I don't know about more often, but they're going to have bigger, more violent volcanoes. Where the spreading center might have volcanoes, they're not going to be very active. So, and if they are active, they're going to be very small. If they're talking about explosive, it's not going to be very explosive at all. We don't see the middle of the oceans exploding at any point in time. The Himalayan mountains are being formed the Himalayan mountains were what we saw with India, where India broke off of Africa and sped up towards Asia. The Himalayan mountains are being formed up here because India is smashing into Asia there. So that's why the Himalayan mountains are being formed. Continental drift separates 2 populations of the same species. Eventually, the 2 populations evolved into distinct species. In which of the following scenarios would this evolution likely be most pronounced? That shouldn't be too hard. Which one's going to make the 2 species the most different? That'll help you out a little bit. A geologist is studying the lithosphere along a transform boundary. Which of the following may the geologist conclude? Just remember that in transform boundaries, nothing's being destroyed or created. They're just sliding past each other. So nothing's being pushed under or pushed up, just kind of scooting on past each other. A geologist is studying rock units at a convergent boundary. The rocks may have been deformed as what happens at a convergent boundary. As they're coming together, what's going to happen to them? Yeah, that's not a great question. The rocks may have been deformed as... I'm going to guess it's both. I'm going to have to look and see if any of these make sense. That's what I'm thinking. It's not a very good question, but I guess it technically would be both A and B. Rift valleys form at which kind of boundary? So a rift, what's happening in a rift, and what kind of boundary would that be happening in? I wasn't asking you for the answer. It's just a hypothetical in your own mind. A geologist is looking for evidence of early supercontinents. Why is the evidence difficult to find? So the early supercontinents are going to exist a very, very long time ago. It's the older something is, there's reasons why evidence is harder and harder to find. So if you have any questions or need any help, please do the reading or let me know and I will help you figure out exactly where to find the answer. Everybody enjoy their 3